Welcome back, everybody. Today we are going to be looking at the first lesson of Unit 10. This is lesson 10-1, which is on adding and subtracting polynomials. So let's get started by first talking about what a polynomial is. Camera fixed here. Okay, so this is lesson 10-1. And it is on adding and subtracting polynomials. We are also going to be talking about classifying and writing in standard form. So, first of all, we've talked about monomials. Pretty much the entire unit 8 was all about monomials. So monomials have the prefix of mono, which means one. And so this is one term. So we might have like 4x squared y is one term. That is a monomial. So poly, the prefix poly, just means many. So many terms. So we're going to talk about polynomials, are many terms. So a polynomial could be something like 4xy squared plus 6xy plus 8x minus 8. So that has 4 terms, so therefore that is a polynomial. We are going to particularly be working with binomials, which would be like x squared plus 6, where there are 2 terms. We're also going to be working with trinomials quite a bit in this unit, which would be like x squared plus x plus 2. So there's 3 terms, so therefore it's a trinomial. So first of all, we're going to talk about the degrees of a polynomial. And the reason this is important is it will actually lead us directly into how to write things for standard form. So if we are trying to find the degrees of a polynomial, we are going to add the exponents of each variable in a polynomial. So, and these have names. So if we add the exponents, so this would be like if we had 4x to the third y squared, that would have a degree of 5 because we are adding the exponents on the variables. Now, I don't care about the coefficient and the exponent on the coefficient. That part doesn't matter. What does matter is just the exponents on the variables themselves. So some of these has special names, and we're going to talk about their special names. So if the sum of the monomial, the exponents of the monomial, and then we're going to have an example, and then the degree name. So the first 6 of these have really funny names, and then from there they get a lot easier. So we're going to go down 1, 2, 3, 4, 5, 6 lines because it's easier if we start 6 down here. So if the sum is 6, so for example, I might have 4x to the third, y to the third. So in this case, the sum of my variables is 6. The exponents on the variables is 6. This would be, oops, sorry, I wanted a 5, not a 6. That's squared. So the sum of would be 5. So this would be called quintic, or to the quintic degree. If we have 4, so let's say this would be 2x squared y squared, we would add the variables, exponents on the variables together, and that would create a 4. That would be called to the quartic degree. And if you think about the prefix core like quarter, there's 4 quarters in a dollar. So if we have 3, so this would be like 5x cubed. So that one has a sum of 3. That would be called cubic. If we have 2, like 4xy, so this one has a 1, this has a 1. If we add them together, they get 2. So 2 is going to be quadratic. And this is primarily, we're going to be talking about quadratic equations in this unit quite a bit. If there's a sum of 1, so this would be like 3x. Well, this is kind of like y equals 3x plus 2, or y equals mx plus b, which makes a linear equation. So it is called linear degree. And then if the sum is 0, in other words, there aren't any variables at all to add, so just maybe a number, that would be called a constant degree, which makes sense because a number by itself is just a constant. So from there, then we go to the easy ones. So if there is a sum of 6, it's just called the 6th degree. If there's a sum of 7, it's just called the 7th degree. 8 is 8th degree, and so on, and so on, and so on. And so that is how we decide the degree. Now, if we have a polynomial, say, for example, we have 6x squared y plus 8x to the third y to the fourth minus 10xy squared plus 8, then to get the degree of the polynomial, so degree of polynomial is the largest of the terms. So it's the largest degree. So the largest degree is the degree of the entire polynomial. So this one is a 3, this one is a 7, this one's a 3, this one's a 0. So therefore, because this guy is the largest, this has the entire polynomial together is the 7th degree. So now let's talk about, well, why do we learn this? We learn this because this is what leads us directly into how to write polynomials in standard form. So if we are going to write in standard form, we are going to put the terms in degree order from greatest to least. And that's how we write in standard form. So for example, let's say we have negative 4x to the third y squared plus 10x to the fifth y to the fourth minus 12xy to the fourth, let's do to the third, plus 6xy minus 12y to the third minus 8. So let's say we got this big old polynomial. None of these can combine because none of them are like terms. They don't have identical variables. So we're going to go through and we're going to find the degree of each term. So the degree of this term would be 3 plus 2, which is 5. So this is the quintic degree. And then the next one would be 5 plus 7, which is to the 9th degree. That one doesn't have a special name. This one would be 1 plus 3, which is 4. So this would be a quartic degree. And then this one is just 1 plus 1, which would be 2. So that's the 2nd degree, which is called quadratic. And then this one is a 3, so it would be called cubic. And then the constant by itself is 0, so it's just a constant. So those are all of the degrees. So we are going to say that this has a 9th degree because it's the biggest one. So if we are going to put this in standard form, we are going to write these in degree order from greatest to least. So our first one is the 9th degree, so 10x to the 5th, y to the 4th. And then our next one would be the quintic, so minus 4x cubed y squared. The next one would be quartic, so that would be minus 12xy to the third power. And then after that would be the cubic one, so minus 12y cubed. And then the quadratic, so plus 6xy. And then finally, the constant. So this is in standard form because each of the degrees is reducing, so it's going from greatest to least in degree order of the monomials. So now what happens if you have two of the same? So for example, let's say we have a 5x squared y to the third, and we have a negative 4xy to, let's make that a 14, xy to the fourth power. So those have the same degree, so which one goes first? So we are going to go to the absolute value. So in other words, we're not going to worry about positives or negatives. We're just going to pretend they're all positives. So go to the absolute value of the coefficient and order greatest to least. So if they have the same degree, then we go to the coefficient and we look at the coefficient and we don't worry about positives or negatives. So if this one has a degree of 5, this one has a degree of 5, we go to the coefficient. So we've got a 14 and a 5. Again, we don't worry about the negatives. We just worry about the absolute value. So we would say that negative 14 xy to the fourth would go first, and then 5x squared y cubed would go next because 14 is larger than 5. So that is writing in standard form. We use the degree measurements to do that. And then the last part is review. We've been doing these for a while, is just to add and subtract polynomials. We're going to be using trinomials quite a bit with these. So my example is going to be, say we are going to multiply the trinomial 4x squared plus 2x minus 1, and we're going to subtract that from 3x squared plus 6x minus 2. So we know that when you have parentheses, there's always a constant in front. So this negative is problematic because there's actually an invisible one sitting right there. And that invisible one has to be distributed to everything on the inside. There's also a 1 right here, but it's a positive 1 because there's no negative. And so we don't need to really worry about this because a positive 1 times anything is not changing anything. So 4x squared times positive 1 is just 4x squared. It doesn't change. So anytime we have a positive 1 in front, we literally can just drop the parentheses. We don't need them anymore when we are adding and subtracting. But this guy, we have to distribute all the way through because it's a negative. So we would have negative 3x squared plus, minus 6x plus 2. And then from there, we're just going to combine like terms. I'm also going to write them in standard form as I go. So if I have a 4x squared and a negative 3x squared, I just have 1x squared. And then if I have a positive 2x and a negative 8x, I would have negative 4x together. And if I have a negative 1 constant and a positive 2 constant, I would have a plus 1 for a constant. And so this, notice that it is also in standard form. This would be a quadratic degree because this guy is a 2. And that's all to adding and subtracting polynomials. So if you have any questions or concerns, please feel free to come and see me. I'd be more than happy to do some more problems with you or to answer any questions you might have. So until next time.